Homework 2.2, more on functions, video 10. Homework due Friday, May 22nd, 2020 at 11:59 p.m. This will be the last video in this homework series. Went a little bit longer than I thought, but I had a lot to say. We're going to calculate one more difference quotient, but this time for a quadratic function. Quadratic because its highest power is x squared. You probably know that the graph of this is a parabola. I could even tell you more about the parabola. I'm going to do a little bit of smoke and mirrors in my head. I'm going to figure out what the graph of that looks like. Let's see. 1, -1, -1, 2. The graph of it kind of looks like this. For reasons which we will discover later, I know that the bottom of this graph is at -1, 2. Let me double check that just to make sure. Yes. How did I get that? Don't worry about that now. I do know what its y-intercept is. That's pretty easy. Just think about it. If you're on the y-axis, your x is equal to 0. And if I put an x equals 0, I get 0,3. So I know what the graph of this looks like. But let's calculate the difference quotient for this. And I think what I'm going to do, I know I just said this was the last video, but I'm going to put an optional 11th video after this, kind of talking about the calculus implications of this. So if you happen to be heading towards calculus, I strongly recommend watching the 11th video. However, it will not contain anything that you need to know for your homework assignment or for your test in this class. It is purely optional. But let's evaluate the difference quotient. Remember, by definition, a difference quotient is this expression, f of x plus h minus f of x over h. So let's go ahead and just write that generically. That's a good start. And the hardest part about difference quotients, at least at this level, is calculating f of x plus h. So let's take that out to the side and work it individually. This one's going to be a lot more congested than the last one because of the fact that it's quadratic. To evaluate f of x plus h, I just have to write the function but change each x to parentheses. So let's do that first. Parentheses squared plus 2 times parentheses plus 3. And then substitute x plus h into each parentheses. Now I've got a big mess to clean up. The middle's easy, I distribute the 2. But how do you square x plus h? I give you a hint. You don't distribute the square. I had that rant in a previous video, but you cannot distribute powers across an addition sign. To square something means to multiply it times itself. So I would have to write the x plus h twice and then FOIL it out. I'll go ahead and distribute here because I can. So we get plus 2x plus 2h and then a plus 3. There is actually a formula for squaring a binomial. For some reason, I don't emphasize it too much, but basically you do square both terms, but in the middle you put twice the product of these. But it's okay to just write it out twice and FOIL it. Now I'm going to spare you the details, but I'll speak them, but I won't write them. The first part is x times x, which is x squared. The outside is x times h, which is xh, but so is the inside, so we get 2 xh's. And then the last part is h times h, which is h squared. So when you square x plus h, you get x squared plus h squared, in the middle, plus 2xh. And in general, you do square the pieces, but you add twice the product in the middle. Oh, and we still have these pieces over here. Plus 2x plus 2h plus 3. So when you bust things open in parentheses, you typically look for like terms to combine. Well, guess what? I don't have any. This is the only x squared term. This is the only xh term. This is the only h squared term. This is the only x term. This is the only h term. This is the only constant term. So we got a whole bunch of stuff, none of which combines. But that's okay. Let's get our function set up. Our difference quotient set up. So I just busted open f of x plus h, so let me carefully bring it all up here. X squared plus 2xh plus h squared plus 2x plus 2h plus 3. Okay. Second part, subtract the original function. Now in the previous video, I put a minus, opened up some parentheses, and wrote this function inside of it. But the thing that happened immediately afterwards is the minus got distributed. So let's get right to that part. If I subtract this entire function, this minus will get distributed to all three pieces, and they will all change signs. So minus x squared, minus 2x, minus 3. And there's an h on the bottom. And do you remember what I said would happen at this point, at this level of difference quotients? Lots of stuff on the top is going to cancel, but the general rule is if it doesn't have an h, it's going to cancel. The x squareds cancel, the minus 2x's cancel, the 2x's cancel, and the 3's cancel. And if you notice, all three remaining terms all have h's. Now why is that important? You'll see in a second. Let me partition this. Let's see what's left. We'll go monochrome. 2xh plus h squared plus 2h. Now, why is it important that everything has an h? Well, can we reduce this? No, but yes. If you're tempted to cancel this h with that one, stop. This h is embedded in an addition problem and it's not eligible for canceling. Same thing with this h, same thing with this h. But we've ran across this situation before when we were simplifying solutions to the quadratic formula. You can't cancel parts of addition problems, but if you have a fraction with an addition problem on the top only, you can split it into multiple fractions. Unadd the fractions, if you will, by taking them back apart, all with the same common denominator, and then giving each term in the numerator its own fraction. So 2xh, h squared, and 2h would be the numerators of those fractions. That removes the plus sign from the fraction, and now every fraction is eligible to reduce. So in the first fraction, the h's cancel, and we get 2x. In the second fraction, we have a power on top of a power, so we subtract. 2 minus 1 is 1, so I'm left with a single h. And in the last fraction, the h's cancel, and we're done. So the difference quotient for f of x equals x squared plus 2x plus 3 is 2x plus h plus 2. And again, outside of a calculus context, this just looks like something that somebody came up with for whatever reason, probably to torture college algebra students. But embedded in a calculus context, it is, I can't stress how important the concept is. Maybe not this one specific problem, but the concept of a difference quotient. So that being said, that ends this video and the video series for this homework. As I mentioned at the beginning of this video, I am going to create an 11th video, but I want to emphasize that it is optional. It will not be on your homework. It will not be on your test. It won't be on anything in this class. But for those of you who are eventually heading towards calculus, I want to give you a preview of how this is used, because it's really not that hard to understand, and I can actually explain it with very little calculus speak. So if you're going to watch it, great. If not, then this is the end of the videos for homework 2.2.